Hello, and welcome back to another IB Math speedrun with me, Vince. In this speedrun, we're going to be going through continuing how to use derivatives as graphical analysis, and we're going to be going through how to use the second derivative to determine the nature of a turning point. So let's jump right in. So earlier we were testing for the nature of a stationary point by getting the values around it, which would get the gradient. And so one gradient was negative, one gradient was positive. It means that this is a minimum point, and if the gradient before is positive and the gradient after is negative, it means it's a maximum point. But there's actually an easier way to do this, which will save you time, and that's by getting the second derivative. So if we know that the first derivative is 0, then we can use the second derivative to determine what point it is. And the reason behind this is because the second derivative tells us the gradient of the first derivative. And so, say our graph looks like, let me just pull up Desmos, and I'll show you what I mean. So, if we have the graph of, say, x cubed, or actually, let's minus x, so we have a more interesting graph with a local maximum and minimum. So if we get, say this is f of x, then if we get f dash x, it tells us the gradient at each of these points. So as you can see, the gradient, we can tell at this point it will be 0, and this point will also be 0, because these are local minimum and maximum points. And in between these points, it will be negative, otherwise it will be positive. So to get the nature of these stationary points without actually calculating the gradient around them, we can simply get the derivative of the derivative, which is the second derivative. And that's the reason is because if we know that the gradient here is 0, if the gradient of the derivative is going up, it means that this must be a minimum point. Since if the gradient of the derivative is going up, all the points above this turning point will have a positive gradient, and all the points below this turning point will have a negative gradient, and so this will be a minimum, and the same for the maximum. So as you can see at this point, 0.577, we have a positive second derivative, which tells us that this is a minimum, and conversely over here at negative 0.577, we have a negative second derivative, which tells us it's negative. So we can use this to our advantage. So if this is 0, if the second derivative is positive, then we have a minimum. If the second derivative is negative, then we have a maximum. And if the second derivative equals 0, this is inconclusive. This is inconclusive, and so we need to go back to our original test of getting the gradients on both sides. Because in some cases, a turning point might not necessarily be a minimum or a maximum, but we'll get to that at a later stage. For now, let's jump into some questions. So, I guess I will do let's say the even ones. I think I've been doing those already. So, we have the function f of x is equal to x cubed minus bx, where b is greater than 0. And it has a turning point at x equals 1. We want to find the value of b. And okay, so first we want to find the value of b. We can do that by getting this derivative of this. So we know that f prime of x will be equal to 3x squared minus b. And so there's a turning point at x equals 1. So we have 0 is equal to 3 times 1 squared minus b. And so b should therefore equal 3. So b is 3, so we can replace b here with 3. Okay. And so there are some more sub-questions, so we need to find the coordinates of all turning points, and it would be very helpful if I've not just erased what I wrote. So we need to get the derivative again. It's lagging. There we go. F prime will be equal to 3x squared minus 3. This is equal to x squared minus 1, so that's equal to x plus 1 times x minus 1. So we will have turning points at both x plus 1 and x minus 1. And we need to get the coordinates, so let's just substitute these into here. At x equals 1, we have 1 cubed minus 3 times 1, so that's negative 2. And at x equals minus 1, we have negative 1 cubed plus 3, which is 2. So we have turning points on both of these. So finally, we need to sketch the function. And in order to sketch the function, we need to know what are the nature of these turning points. And without knowing anything about cubic equations, of course, if you knew something about cubic equations, you could probably do it by sight. We know that f double prime will be equal to 6x. So if we substitute 1 in, we get a positive, so this is a minimum. And if we substitute negative 1, this is a maximum. So therefore, since that's a minimum and that's a maximum, the graph should look something like this, with a maximum on the negative side and a minimum on the positive side. So it should look something like this. Of course, this being 1, this being negative 1, this being 2, this being negative 2. Okay, on to the next and final question. Yeah, there's not too much to learn about the second derivative, you just need to start applying it. So we have the function f of x is equal to x cubed plus bx plus c, and we know it has a turning point at 1, 4, so we need to find b and c and find any other turning points. If it has a turning point at 1, 4, again we have f prime is equal to 3x squared plus b, so we have has a turning point here, so 0 is equal to 3 times 1 plus b, so b must be equal to negative 3. And this coordinate is on the graph, so 1, 4 is on the graph. And as this loads, we have x cubed plus minus 3x plus c. If the coordinates 1, 4 are on the graph, this means 4 is equal to 1 minus 3 plus c, and so c must be equal to 6. So we have x cubed minus 3x plus 6. So we need to find the coordinates of any other turning points. So we have over here, we know this is minus 3, so 3x squared minus 3, giving us the exact same equation as last time. And so we know this factors, so we will have a turning point at x equals 1 and negative 1. So let's find the other turning point at negative 1, or the coordinates. Negative 1 cubed plus 3 plus 6 is equal to 8. And so now, well, let's just find the nature of these turning points for fun. Except that they should be the exact same as the last scenario. So this should be equal to f prime is equal to 6x. So of course this is a maximum and this is a minimum, since 1 is a positive integer and negative 1 is a negative integer. So yeah, that was pretty much it. I hope you enjoyed the speed run, and I hope to see you in the next one.